So for 80, the function is continuous from -2 to 1 and differentiable from -2 to 1. If f of -2 is equal to -5 and f of 1 is equal to 4, which of the following statements could be false? Okay, so they gave me this intro talking about things being continuous on the closed interval and differentiable on the open. So remember, we've got a few theorems like the intermediate value theorem and the mean value theorem that apply when these things happen. We're looking for the statement in which things could be false. So there exists some c between -2 and 1 that c is equal to 0. So if I drew a little bit of pieces here, right, I've got -2 being a negative number, and then I've got 4 out here being a positive. So if I'm switching from positive to negative, I have got to have equaled 0 somewhere in between there, right? That's the intermediate value theorem coming into play. So A is definitely true, because somewhere on that graph, we definitely cross the x-axis. There exists a c where -2 to 1 such that the derivative is equal to 0. So remember, the derivative equaling 0 is a critical value, and we're assuming that somewhere between here, because we switched from negative to positive, right, that we had some sort of a switch, but we don't know. It could have been a cusp, it could have been a corner. We're unsure of if it's actually where the derivative is equal to 0 or if it's possibly undefined. So B there ends up being the one that is false, but let's keep going and talking about them. Here there exists some C where f of c is equal to 3. Again, when we're at -5 to 4, 3 is in between there. So because of that intermediate value theorem, that does exist. For D, we're talking about the derivative. So we're checking the mean value theorem. So what I'm going to do is find the slopes of these lines. I'm going to say 4 minus -5 over 1 minus -2. All right, so that gives us 9 over 3, or 3. So according to the mean value theorem, that's true, because we do have an average rate of change that would match our instantaneous rate of change. So that is true. And then we've got E. There exists some C such that f of c is greater than or equal to f of x on the closed interval from -2 to 1. So this graph is increasing between those 2 points. So if we're increasing, we're going to be greater than that f of x. So B is our final answer.